How can you charge such a large battery pack? Well, one way would be with a 400 volt power supply, which is available for around $200 on eBay, but that would not really allow BMS, or battery management, cell balancing, measurement of each cell voltage, etc. And so built onto my packs are these DB25 connectors, each supporting 24S, which means there's 4 of these total. So I have 2 modules. This is one of the modules that's completed, and this is the other module that's under construction. And so each of these DB25 connectors can be used alternately with this charging harness, which brings it out to 4 standard 6S connectors connected to an inexpensive balance charger. And so right now this charger is charging 6S of this 96S pack. This has to be moved 4 times amongst these balance connectors, and then the DB25 has to be moved 4 times among the 4 DB25 connectors to fully charge the battery. Now, while this may seem time consuming, it is very, very inexpensive, yet still expandable in the future to a more advanced automatic sort of self-charging BMS, which is with the pack all the time. The second thing I wanted to show during this video is the completion of this pack. And you may remember that we used this pack to power a 120 volt AC light bulb at the 160 volts approximately that this battery is right now, seeing as how it's only half of the full voltage. And so another alternative to powering a light bulb is to power a standard switching power supply such as this one. And in fact, this power supply, good for 100 to 240 volts AC, is also good for 160 to 320, 350, or say 400 volts peak lithium ion packs. And so I use this orange Anderson connector, orange wires. This indicates the high voltage so that I don't inadvertently connect it to one of these red and black Andersons, which is 24 volts or DC power. Or as well, I also use these yellow and black Andersons, which are specifically for 12 volts DC, although I use the red ones sometimes out of necessity. But the orange ones are expressly for the high voltage DC, and so as you can see, I've simply connected that directly to this switching power supply. Internally, the first stage, past the AC filtering, which is basically just a series inductor, which is unaffected by the DC power, is a bridge rectifier, again unaffected by the DC power, and so the polarity between plus and minus, line and neutral, is unimportant. Following that, it goes on to the internal supply's main bus voltage capacitor, where, guess what, it's DC again, and so it seems to work just fine. So I have this connected. This is the main pack switch, so when I flick it on, we get our green light, and we're powering a 35 watt halogen light bulb at 12 volts. Alternatively, this could power any other electronics. I happen to be building a lawnmower for starters, and so that lawnmower will have control electronics, which will need low voltage DC power. In reality, most likely I'll be using a separate 24 volt lithium ion pack to power the electronics in order not to have the weight loss of a power supply, but it's good to know that it is a possibility. Finally, and third, I just wanted to show my testing setup right here. And so we have 2 chargers going, my favorite being this Litocala Engineer LII-500. And so as you can see, it supports 4 cells, and it is measuring the capacity of each one, as well as the internal resistance, the amount of time it takes to complete the operations, and then the individual cell voltages. And pressing these buttons shows you the different parameters for each of the cells in the charger. I also use this other charger, should let you know the model number. It's a Zanflare C4, which I don't like as much because it's about half the speed. However, it seems to be a little bit easier to use in my opinion, so I like both of them. To buy more, I'd probably purchase more Litocalas because of their speed. This one I'm using for peaking the cells, so because I've been charging cells on the IMAX B6, the Litocala Engineer LII-500, and the Zanflare C4, each of the cells that I charge end up being different voltages, and so to make sure that they're all the same before building the pack, in order not to have to start with balancing, I finish all of the cells on this charger, it being the highest voltage charger of them all, peaking the cells around 4.18 volts in reality, even though it says 4.2. The Litocala seems to peak the cells around like 4.15, I think, which is quite close, and in reality we could build a pack with that. And then finally the IMAX B6, which seems to only bring the cells up to about 4.09 volts, and so those cells definitely need to be topped off using the highest rated charger. Following that, I set the cells over here and we slowly construct the battery pack. One thing I would like to note is that on the previous pack that I built right here, one of the cells was upside down. I didn't notice it until I put the top on and was actually welding everything together. I created a short circuit. Luckily it wasn't a big deal, it's very brief, just okay, that's not good, and so I removed it. In order to fix the problem, I actually had to use a razor blade, cut out these little tabs, and press the cell through the pack, turn it around, shove it back in, and then weld it back in with the nickel strips. So just watch out for that. Again, this is my charging station. It's